Hi, Assalamualaikum. My name is Muhammad Kusairi bin Johari, and today I want to represent the hydrostatic force on plane surface. Okay, for the introduction, the fluid properties and hydrostatic study has been designed to demonstrate and provide students with hand-on experience and fully understand how the properties of fluids and the behavior under hydrostatic condition. Application of Pascal law and Archimedes law important to determine properties such as density, viscosity, and surface tension of fluid. Okay, the objective. Okay, now we will go to the objective. Okay, to analysis and compare the experimental result with the theoretical value. Okay, this is we want to uh, see the different value of the experimental result with the theoretical value. Okay, next one is to determine experimentally the magnitude of the force of pressure, hydrostatic force, and its point of action, center of pressure on both submerged partially submerged plane surface. Okay, this objective is because we want to see the purpose of the experiment. Okay, this is the apparatus and this is level indicator. This is the apparatus and balance arm, clamping screw, knife edge pivot, counterbalance, a scale. The scale is for the measurement and to record the data. This is weight hanger to hanger the weight. Okay, this is spirit level, adjustable feet, quadrant, and drain valve. Okay, the drain valve is used to when you done the experiment, the drain valve will be opened to flow the water again the tank. Okay, so this is the tank. Okay, this is a procedure. Step 1, place the hydrostatic pressure apparatus on top of the bench. Okay, step 2, make sure the apparatus is installed properly. Step 3, the apparatus was being leveled using adjustable feet facilitated by spirit level attached. Step 4, the counterweight is adjusted to level the balance arm to horizontal position. And step 5, make sure that drain valve V16 is closed and slowly added water into the tank until the surface just touch the quadrant base, thus establishing a datum level corresponding to 0 at the level scale. Step 6, a 50 gram weight is placed on the balance pan and water is added slowly into the tank until the balance arm is again horizontal. Step 7, record the mass of weight M and depth of immersion D in the experimental sheet data. Step 8, Step 6 and Step 7 were repeated with an increasing number of weight until the tank is full of water. Step 9, the water is drained off after done the experimental. So the drain valve will be opened. Okay, this is the procedure. This is the picture of the procedure for step 1 until step 9. Okay, this is the picture of the calculation. They have a calculation of recorded data, calculation finding second moment experimental, and the third one is calculation of second moment theory, and the fourth one is calculation error. So this is a picture of the calculation for the uh, so I will record the video how I get the value of the all this calculation. Okay, this is the calculation video. So I will show you how I get the value of the second moment experimental, second moment theory, and how to calculate the recording data.
Hi, Assalamualaikum, and this is the calculation of the recorded data. Okay, now we will calculate the finding resultant hydrostatic force, the partial immerse. Okay, we use the formula F equal to rho G B D square over 2. Okay, for the rho is density, G is gravity, and B is the weak quadrant. D square is gap of immersion. Okay, we will use for D equal 0.066 meter. Okay, to calculate it, we just substitute all the given information about the formula, and then we just substitute the value. 1000 times 9.81 times 0.075 bracket 0.066 square over 2. So the value of the value of the finding resultant hydrostatic force is 1.6025 Newton. Okay, now we will move to the full immerse. Okay, the formula is F equal to rho G BD bracket D minus D over 2. Okay, this D is the height of quadrant. So for D equal to 0.108 meter. Okay, we just substitute the value of D. So 1000 times 9.81 times 4 times 0.075 times 0.100 bracket 0.108 minus 0.05. So the final force resultant hydrostatic force is 4.2674 Newton. This is the calculation video for finding resultant hydrostatic force. The top one is for partial immerse and the bottom one is for full immerse. Okay, now we will go to the calculation to find second moment experimental. Okay, the M is for mass, G is for gravity, and L is for length of balance, and F is resultant hydrostatic force. Okay, so if M and M equal to 0.09 kilogram, okay, this is partially immersed. So we just substitute the value of M to the formula. Okay, so H apostrophe equal to 0.09 times 9.81 times 0.275. Okay, divided by force, which is 0.7784. The resultant force is already calculated, so equal to 0.3119. So that is a final answer. And the formula, partially immersed and fully immersed, is the same formula. We use the same formula. Okay, now we will go to the how to calculate the second moment theory. Okay, this is formula for partially immersed. Okay, H is stand for quadrant, the two pivot, and D is that we already know, which is the gap of the immersion. Okay, now we will go to the fully immersed. This is the formula for the fully immersed. Okay, D is for gap of immersion, and so we use D minus capital D over 2 bracket and square plus bracket D square over 12 over D minus capital D minus 2 plus H minus D. Okay, so for the calculation, first D equal to 0.046 meter. So we just substitute the value of D is 0.16 minus 0.046 over 3. So the final answer is 0.1447 meter. Okay, this is for partially immersed. For the fully immersed, we use like D. Okay, for number 5, D equal to 0.108 meter. So we just substitute the value of D, which means 0.108 minus 0.05 okay, plus 0.01 over 12 over the 0.058 plus 0.16 minus 0.108. Okay, so the final answer is 0.1244 meter. Go to the calculation of error. So we use this formula for partially immersed and the fully immersed. I use the same formula. So H prime theory minus H prime theory minus H prime experimental over H prime theory times. Hi, Assalamualaikum, and this is the calculation of the recorded data. Okay, now we will calculate the finding resultant hydrostatic force, the partial immerse. Okay, we use the formula F equal to rho G B D square over 2. Okay, for the rho is density, G is gravity, and B is the width quadrant. D square is gap of immersion. Okay, we will use for D equal 0.066 meter. Okay, to calculate it, we just substitute all the
Okay, this is the data recorded. Okay, this all the value. Okay, all the value have been recorded into the table, so it easier to me to plotting the graph and show the result. Okay, this is graph plotting and creation. So uh, this is how I graph plotting and creation. We key in the data in the lab sheet. After we key in data, we zoom the table. So after this, we key in the value that we got from the handwritten. So I used to do the calculation in Excel because it easier to get uh, the value correctly. So we just key in the data. After we key in the data, we used to do the graph by clicking the graph, how pattern that we want. So we take the x and y axis, and then we highlight it and take the value to do the graph. So after we done the graph, we just rename the graph, the x-axis and y-axis. Okay, that's how I do, and that's how I graph plotting and create the graph in this experiment. Okay, I think that's all for graph plotting and creation. Okay, this is the graph of result. Okay, the y axis is resultant hydrostatic force, and the x-axis is a second moment for both experimental and theory. Okay, so we just put the value into the Excel and generate the graph like this. Okay, this is discussion based on discussion in the lab sheet, so this is the answer. Okay, first, the experimental value are larger than theoretical value. A second weight needs to be added as well until the weight until the unit is balanced when water is added in order to reach stable equilibrium. Number 3, center of pressure is not at the center of the body because pressure increases with depth. Center of pressure is determined by the movement of resultant force to the movement of distributed force. Okay, number 4, calculated error. When the value are not calculated correctly or the value are wrongly written on the data table, this could affect the real value of the experiment. Instrumental error. When the instrumental used in the experimental faulty, this may impact in the final value of experiment. So number 5, the last discussion is, dams are built in the way that water side is much thicker because the light is depth, the bigger the water pressure at the bottom. Okay, so we can conclude that the deep, the increase the depth, so increase, so the pressure will increase too. So that is all for discussion, so we will move to the conclusion. Okay, this is the conclusion based on the experiment. I can conclude that the obtained results show large discrepancies between the theoretical and experimental value of the center of pressure, where the experimental ones were larger than the theoretical ones. So in this conclusion, so this is the conclusion for this experiment. So thank you. This is all from me.